find the velocity function, we took the derivative by using the power rule on each term of the position function, since velocity represents change in position over time. To find the initial velocity, we find the velocity when the time is 0 seconds by plugging in 0 for t in the velocity equation. To find the acceleration equation, we took the derivative by using the power rule on each term of the velocity function, since acceleration represents change in velocity over time. To find the object's acceleration at t equals 3 seconds, we plugged in 3 for t in the acceleration function. To find speed, you take the absolute value of the velocity at that time. We plugged in 1 into the velocity equation to find negative 1 centimeters per second. The absolute value is 1 centimeters per second, so the speed at 1 second is 1 centimeter per second. The object moves left when v of t is less than 0, so we set the velocity equation equal to 0 because the object's velocity is 0 when it turns. Velocity is position over time in a direction, so we know that when the interval is negative, it is moving left. Displacement is the distance from the initial position, so we subtracted the initial position from the final position and found it to be 2 centimeters. We used the critical numbers and velocity number line from the last question to add the distance traveled left and the distance traveled right. The object's velocity decreases when acceleration is negative. We made an acceleration number line and found that velocity is decreasing before a half a second. The object's speed is decreasing when a of t and v of t have different signs, so we took the number lines of acceleration and velocity and found the intervals where the sign was opposite.